Hi everyone, welcome to another session of a day in the life of a BA. My name is Marsha Fernandez. I'm a volunteer of IIBA Ireland and I'll be your host today. So, at IIBA Ireland, our mission is to support professionals by sharing knowledge, common terminology, and practical insights into the work of business analysts across different industries. So, this series gives you a chance to look directly from BA professionals about their typical day, their processes, the tools and techniques that they use, and the challenges and success they encounter in the industry. Each month, we invite a BA professional to share their personal journey, highlighting the approaches that they take, the technologies that they rely on, and real world examples from their work. So, whether you're considering a career in business analysis, already working alongside a BAs, or simply just looking to deepen your understanding of the role, today's session is designed to give you clarity, confidence, and a shared understanding for working effectively with BAs. So, today I'm delighted to be joined by Banu Raghuraman, who works as a BA. Banu will take us through her day, demonstrating how algorithmic thinking plays a key role in tackling everyday challenges, making decisions, and solving complex business problems. Throughout the session, please feel free to turn on your cameras for the session to be interactive and submit your questions in the chat box, which we will pick up. So, without further ado, Banu, it's over to you.
Thank you so much, Masha. I do want to extend my gratitude for having me today. I do appreciate the camaraderie with all the IIBA chapters. I'm not based out of Ireland, but the opportunity means a lot to me. Last couple years, I've been traveling to Europe as well for a couple BA events, and it just makes me, wonder at how the community has kind of bloomed and has its own character and its own way of cultural integration that's happening. In fact, I was in Netherlands last year, and this year I had the opportunity to travel to Luxembourg and Belgium as well. And one big thing that I'm very, very jealous of is just feels like everyone in Europe is minimum fluent in three languages. So the polyglot aspect of it is just amazing for me. So kudos. But it's great to meet you all. And I will share my deck here and let me know if you guys are able to see. Um, and as Masha said, I'd like to keep it interactive. The deck will be shared with you afterwards as well if you would like to have a copy of this. And if for whatever reason we don't cover it through a few slides, I'm happy to have offline conversations as well. I'll have my LinkedIn contact included in the deck, so you guys can get in touch with me. I did want to mention one thing. I know the series is called Day in the Life of, but it is the topic at hand. It's a bit hard to kind of compress that into a day, right? And often you have different things that you might think of as your project progresses, but that might not be the only thing that you're looking at on the first day or a specific day. So while the topic is in the day of, maybe AI is going to make it shorter for us, and that's something that I'm going to be covering as well. But algorithmic thinking, in my opinion, is something that you sharpen your skill set as time goes by, as are some of the other soft skills as well, like critical thinking, building out use case scenarios, interaction with stakeholders. Rome was not built in a day, so some of these skill sets will take a bit of time, but definitely we can look into some of the foundational aspects of building this up. The other thing I also wanted to apologize for is that I caught a cold over this weekend. So if at whatever point you're unable to hear me, please let me know because I might start sounding a bit froggy because my throat is getting a bit scratchy, but hopefully I will sustain through the hour. So let's cover this algorithmic thinking in an AI world. And I wanted to set some expectations in terms of what you can expect. And I also like to give a quick background of myself in terms of where I'm coming from. So it gives you a context of why I'm talking about this specific topic and how I approach the topic as well. So I have been in the industry for almost 20 years now. I started off as a developer in the database space. Then I moved into process improvement and I'm a black belt Lean Six Sigma. Then I completed about 7 years in the BA space. I'm a certified CBAP with IIBA. Then I slowly moved into the product management side. I got my PO certification, and currently I've been working in in the product management space. And when we think about all these different aspects, and lately I've been moving into the AI space as well. Currently, I'm working in conversational intelligence, and I work with large language models and machine learning to kind of understand how we can extract data and use that into agents as well. So I'm going into the agentic AI piece. So having gone through that transition of being someone who was actually writing code to someone who was working with developers to kind of understand what they need to build these systems, to someone who's now thinking about user experience and design from a product perspective as well, and having a background in process improvement with Lean Six Sigma. I have a background in statistics, so that naturally kind of flowed into the analytics space that I work in. And I'm also in engineering, so there's a lot of critical thinking in terms of breaking down things into more consumable parts. And I've also done my EMBA, which is essentially the business side of things. So you need to understand how the product, the revenue, and all those aspects, the operational aspects, the logistics, and all those things kind of come into play as well. So I've been very fortunate to kind of have an opportunity to play with all the different types of thinking that we will be covering today in this session. And even though the topic is specifically talking about algorithmic, I do think that no one process is going to be self-sustaining on its own. So you definitely need other foundations, and the ability for us to assess what fits where is what makes us uniquely human, right? So these are things that where we can distinguish ourselves from AI, because this is a very popular question that people are still asking is like, how is AI going to impact my job? Is AI going to take over my job? Not really, but someone who knows AI well can. So these are some of the questions that people have, and I'm hoping that through the analysis that we're going through today, you will get some insight of how you can leverage AI as part of what you're doing. Because ultimately, whatever I'm going to tell you in terms of algorithmic thinking, systems thinking, and design thinking, none of this is going to be new to you. I'm assuming all of you are at least mid-career professionals, and even if you're early professionals, you would have applied some of this in the context of even university assignments. So it's not something brand new that you're looking at. But as humans always love to repackage things in new boxes, I think you might find some new boxes here, new ways of describing things. But I think if you are a good critical thinker, if you have solved problems before, you would have applied a lot of these concepts already. However, what we are going to learn together and maybe have a slightly different perspective at the end of the conversation would be how do we bring this into the AI context is one. And the other aspect is how do you maybe communicate this better to your team as well? And how do you interact with your team? Because ultimately, AI will take over a lot of the laborious jobs that you are in charge of. But that human connection and that human interaction and the stakeholder management is where you need to bring in your niche and kind of bring those insights that perhaps do not exist in the AI repository that we keep referring to. So let's define some of these, let's give some labels to some of the things that we have been using for the past few years. We'll talk about the AI concept. I do have a few case studies just to give you some high level insight into what we're going to do. And last but not the least, I have a quick example of how I put this into a Gen AI tool, and also what are some of the things like I almost have a very, very raw checklist for you to use as something that you can apply immediately when you go back to work, which I'm hoping is tomorrow, considering today's Tuesday night. So let's move on. So the first thing I want to talk about is what is algorithmic thinking? Can I just have a quick show of hands on Zoom if you have heard of this terminology before, algorithmic thinking? You can just use the hands up icon in Zoom. I just want to see if this is brand new topic to you guys or if this is something that you have heard about before. No hands, so no one has heard of this term before? Is that how I should read this? Okay, then maybe a lot of it might be quite new to you. So, in terms of algorithmic thinking, when we think about algorithms specifically, that is really just a step-by-step basis that people use to, specifically coders, used to use back in the day, and even today, I'm thinking to really simplify problems. So if we were to write code in Java and then in C and then in C++, in COBOL, in Fortran, all these different languages, they all have their own syntax and grammar. And for you to fully understand the code, it would have been very important for you to know the language and understand what it's actually saying, what the syntax is. It's almost like reading, the same text in English and French and German and all the different languages. But what algorithm used to do is it used to simplify all the code-based languages into simple English language in saying, assign variable, set variable. And it's just very simple language. And you can just translate that into any language, any coding language. And that was just something that was commonly used. And that's what was called algorithm, which is to say that these are the steps that I would be following in order to achieve my outcome. Now, when we put that into the thinking process, we say it's algorithmic thinking, and essentially that says that you have sequential and step-by-step process. You break it down into the most minute parts possible so that you're able to digest that better. And eventually, when we think about building this into systems as well, I'm guessing most of you are in the IT space as well. If not, you are working within the IT space, within another domain, or you might be working in some sort of programming context where you are interacting with machines. And so when you're interacting with machines, it's not just simply enough to have an idea in human language, but you also need to translate that into machine language. An algorithm kind of falls into the translation layer, if you will. So even though this was traditionally used by developers, as business analysts, as product managers as well, I'm going to include myself in here because I've been in that space recently. It's very important for us to understand what we're trying to break down, right? So our ability to translate the complex word into something that's a bit more simplistic and absorbable and understandable becomes our true value that we're bringing to the table, because a developer might not be spending that much time in trying to understand the world. They have moved into, from solution architecture, they've moved into implementing the solution rather than trying to understand the world. So you being BAs, you guys have to do that translation from complexity to simplicity, and algorithmic thinking kind of helps you break down those steps. And for that, there have been lots of functional tools, and I'm pretty sure you guys have used the business process model notation, perhaps not to its exact grammatical setup, but you've definitely used boxes, you've used arrows, you've used decision points, you use database icons. So those are simplistic ways of determining what the process looks like. You might have used the decision model notation as well. So this is when you've got a tree that's branching out and you're trying to find the information coming out from each of those branches and how that eventually goes into the outcome. And last but not the least, I'm really, really hoping all of you are using user flows and validation rules, exception paths, alternate paths, error scenarios, and so on and so forth to fully define and give that body and volume that is required for requirements to be robust. So all these things are things that you've used before. However, now I've introduced a new terminology, which is essentially algorithmic thinking, which will help you break down things. Now, when in my naive mind, I thought I was the first to come up with this, because about 5 years ago, I was invited to speak at a conference called Grace Hopper Celebration, which is one of the biggest women in tech events here in United States. And what they do is they essentially run this conference specifically focusing for female graduates or people who identify as females, and provide them with avenues for technical careers. So when I was presenting this topic for the first time, I started doing my research and I discovered that voila, there was another very, very smart person who had already written about this topic. But the slight difference was he was specifically focusing on developers and he was specifically focusing on coders. So that being said, Daniel Zingaro, he's the one who wrote the book about algorithmic thinking. And you will see that in his principle, he specifically talks about breaking problems into precise parts. He talks about identifying data structures, and then he talks about having specific rules for them, which definitely sounds extremely technical, but we are going to break down that into a bit more of a business analyst mindset of what it means to break it down, right? All right, let's go into the next slide. So here, with regards to framework landscape, I wanted to give you all the tools that you need in your toolkit whenever you're trying to solve a problem. One of the things that has helped me, I did introduce myself with all the different viewpoints or perspectives that I'm going to bring to the table. But one major thing that helped me with the myriad of viewpoints that I had is now it gives me different kinds of skill sets, different types of school toolkits for me to go in and look at a problem in various perspectives. And that's what I'm hoping all of you as BAs are able to do as well. BAs sometimes start as BAs and they come from traditional backgrounds, but we also have BAs who come from non-traditional backgrounds, so they come from something completely different. And for me, that was the case with regards to product management. I didn't really travel the traditional path of product management as many people would today, but then I bring a lot of perspective and varied insights onto the table or to the table, being a BA and having worked in different domains. So what we're going to be focusing on in this specific deck is going to be the algorithmic and systems design, primarily because that's where a lot of the process breakdown will take place. The design aspect of it, I have a background in user experience design, so there's a lot of focus on, what does a human think? How does the human interact? And this is also going to be a huge question, and I have a separate talk about this altogether, is what is it going to be like to have human in the loop? Google calls it HITL, human in the loop. And basically, what they say is even if you're building AI systems, you cannot really leave out the human from the loop because without the human, you're going to lose the aspect of connection with the tools and the systems that you're building. So that part we're not going to be connecting on in too much depth in this specific deck, but we will go through the algorithmic and systems part, and you will, and I'll naturally point out where it's important to bring the human as well. So you will have some context there, but that is not something that we're going to be focusing on. So algorithmic, system, and design. These are the three, like I would say the holy triad, if you will, from a framework perspective. And then I've also got a second layer here that I wanted to introduce to you if you haven't heard about this before. The first one is first principles. And what this basically says is ignore everything, all the bells and whistles and all the frills in the world, and really boil it down to what is the core aspect that you're trying to solve. And sometimes when you work with extremely complex systems, currently I'm working in healthcare, and often this is a huge distractor, if you will, because when you work in healthcare or in fintech, you're constantly burdened with this thought of, oh, there's a lot of legal complication in here. There's a lot of compliance aspect in here. There's a lot of ethical stuff in here that I need to think about. But when you're solving a problem, if you start getting distracted by a lot of these frills that are supposed to be part of your outer shell, you will be distracted from what you're trying to solve for. So first principles essentially says that remove all these burdens from the outside aspect, right? And really focus on the problem that you're trying to solve. And once you have kind of worked out what that sphere kind of means, then you start including all the outer aspects, and then you have a more wholesome solution to what you're trying to build. And first principles then has the second layer on it, which is the second order principle. And what that is kind of talking about is once you've solved the core problem, once you've kind of understood that, what then? What do you do at the next step? And that's where your external pieces come in. So first principles and second order kind of work hand in hand in the sense that it helps you focus and zoom in and zoom out on a specific problem and look at it in a very digestible chunk rather than looking at it from a big complex ball. And the last but not the least, I like to throw this one in because I come from a Six Sigma background, and that has truly helped me access a set of toolkit that was previously not available to me in terms of thinking processes or even stakeholder management or even some sort of templates. Because sometimes I feel writing down and building something out in a template clearly delineates each component of your idea for you to talk about, right? So Six Sigma has things like 5 Whys, the fishbone modeling. It's got the voice of the customer, the house of quality. All of these are different components just designed to help you jot down your thoughts in a more tangible and digestible manner. And personally, I feel that with AI coming in, and we'll talk about this, I think it's in the next slide. So maybe this is a good segue to go into the next slide. Yeah. So why are these frameworks important with AI? And I will just go into the AI magnification piece because that kind of ties into the Six Sigma piece and root cause identification. So AI is something that is going to help you scale beyond what you had imagined before. So if you go into something, you implement a process with AI support with a lot of bugs in it, what AI is going to do is that it's going to amplify and magnify those bugs, right? So whatever you put into AI, it's going to make it bigger. So if you put something that's more efficient, your efficiency is going to grow. If you put something that's inefficient, your inefficiency is going to grow that much. Which is why I like to throw in the frameworks for Six Sigma, Lean, and root cause identification as well in these frameworks, because often we need to think about before I put it into AI, do I know that it has been streamlined and stripped of any issues that would deviate it from what I intended to do? So that is something that should always be in your mind, because I find that companies now are so taken away by the AI concept, they want to jump on the bandwagon, which is what happened a couple decades back when agile was the thing, right? When it that was all the fury, every company wanted to jump on to agile, but then they didn't really understand how to transition from waterfall methodology to agile. So most people now are focusing on Wagile, which is a combination of waterfall and agile rather than being pure agile. So really understanding what you're trying to build and also making sure that what you have is fully efficient before you jump into that is really important here. The other thing that I want to talk about on this slide is some of the other factors as to why it's important in this AI trend or generation. Instead of and this is not a very positive trend in my opinion, but we built machines for humans. That's how we started. We said that there are lots of tasks that are laborious. We want to bring in machines, we want to bring in automation, and that's going to help us do our job better. But whether we like it or not, it's getting to a point where people are now becoming an afterthought for most companies, not because the original designer of AI really thought so. Like there's this gentleman, Jeffrey Hinton, who's known as the father of AI. He's currently a professor at University of Toronto, my alma mater. And same thing with Daniel Zingaro as well. He's actually based out of Toronto as well, which is my home. And even though originally when we thought about machines, they were supposed to help us humans do a lot of other things, the society and corporate world especially is kind of tuning into a way where humans are starting to become for machines. So we're starting to change ourselves. Like think about the time when computers were not a thing, and then in resumes there used to be a line saying proficient in Microsoft Word, Office, and Excel. And now if you're in IT, that is not necessarily a flex. People expect you to know these things, right? We've moved on to other technologies like cloud software now. So humans have kind of adapted now to the technology that we're working with. And then now we have other applications that we need to be versatile and knowledgeable in. Moving that slider a bit more, the next step is we need to know how to work with AI. We need to know what it means to have Gen AI. We need to know what it means to have AI within your app. We need to know what prompt engineering is. All these things are slowly changing humans to adapt to the machines that we're working with. So in a way, I wouldn't say that we're necessarily competing, but we definitely need to be more in tune with what's happening with the machines. So if your machine now is capable of spitting out 3 prototypes in 3 minutes, then you need to have the fast capability and some sort of a template or ability to say which one of those 3 prototypes will work best for what you are doing. You cannot necessarily go and say to your boss, okay, my computer spit out 3 prototypes, but then I need a week now to analyze which prototype is the best, right? So you also need to kind of move faster and in the same pace as the system is giving back to you. If you don't, then you're kind of falling back in the same kind of duration of time that it takes to complete certain tasks. So while I'm not saying that we are slaves to machines, to some way we need to adapt ourselves to the pace of machines that are moving. So when you have these frameworks available at your disposal, it becomes easier for you to get through what you need to get through from a daily perspective. Next thing is analysis automation. Whether you like it or not, all the things that you're doing, someone out there is probably doing it faster because they've automated their work, right? There's always going to be exceptions, of course, and that's where humans come in. That's the reason why we need to be in the loop. But apart from that, if you think about it, if your tasks are actually repeatable, and you kind of know what kind of results you're getting to, and this includes BAs as well. For example, writing requirements document. If you are building, say, an appointment scheduling system, it's not going to be very different from, say, Microsoft Office calendar appointment scheduling system, right? So the system is able to leverage a lot of the information that's out there and build something for you. So knowing what parts you are able to automate versus not becomes a key skill for you because now you can outsource those pieces to AI and you can focus on more strategic things and being more of a human in the loop rather than being the only human in the entire process, right? So that really frees up a lot of your time. So having that insight to constantly think about what are the pieces that I can automate will become your unique flex. And last but not the least, show your work is going to become very, 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 very important. I cannot stress the importance on this one, especially with AI, because now people are throwing in prompts into all these different models. They're getting all these outcomes, but at some point, the answers are going to become really crucial where people will be questioning, okay, I see what you've given me, but how did you arrive at this conclusion, right? What is it that you used as your supporting documentation? Gen AI tools are slowly getting better at this, whereby they show you the entire list of the source material. But really, showing you the source doesn't really do much unless it shows you what work it's done. And I use two tools very often. One is Gemini, and the other one is Perplexity. I do use Chat GPT as well. I started using Claude recently, just a small bit, but most of my work is done between Gemini and Perplexity. Gemini is really good, in my opinion, to translate and speak the human language, so it's able to grasp a lot of the social connotations and connections, while I find Perplexity is really good at deep research. And if you're able to use some of the deeper models in there, you'll find more information as well. And the end of the session today, I'm hoping to share a quick example that I popped into Gemini as well. But you will notice that in Perplexity, as it's thinking through some of the things, it will give you some temporary information on how it derived and arrived at the specific conclusion that it's giving you. Whereas Gemini will not necessarily do that. But you can prompt and ask it. It won't, doesn't prevent you from doing that. But that differentiation of showing the work is going to be a huge differentiator in terms of your ability to trust the model that you're working with. And when you think about, huge decisions that we're going to be outsourcing to AI models, this is going to become huge. And if you are instrumental in building some of these AI tools as well, you need to understand what are the steps that I need to do to ensure that I've shown my work to the user trusts my opinion and my answers, and I'm also going down the right path. It's not just about the trust, but are you going down the right path? Like when we think about, one of my favorite examples to talk about when we say show our work is the BODMAS concept in mathematics, right? So when you just have a plain statement that says fly 5 plus something divided by 2 times 2, people calculate that differently. But unless you follow the BODMAS methodology, you're probably not getting to the right answer there. So showing that work as to how you thought through, someone can go back and correct the work and saying that, hey, this is not exactly the order. You need to think about BODMAS because you've got the brackets, you've got off, you've got division, multiplication, addition, and subtraction. And as the complexity increases, there's going to be more as well, right? Same thing with, say, someone's asking for accounting rules. Are you thinking of the accrual system? Are you thinking of the cash only system? Are you talking about the gap principles? Are you using some other principles? What are these different things that you need to explicitly tell your user before your outcome is accepted? I get super excited with AI, so I tend to get a lot more derailed when it comes to these conversations. But hopefully that gave you some insight into why it is important for you to think about some of these frameworks and start applying them as well. All right, moving on to the next slide. Now, these are the three lenses that I would specifically be focusing on in conversation today. We'll go a little bit more deeper into algorithmic lens, and the system lens, we'll touch on it a bit, and design lens, I'll bring it in from time to time because that's the human element. This triad can also be superimposed on another triad that BAs very frequently use, and that's people, process, and technology. So people kind of falls into your design lens. That's where you think about how are users interacting with various aspects? How are they connecting with the application that you're building? Your system lens is where your technology comes in. What are the different integration points? What are the downstream applications? What are the data points? How do I need to build my cloud software? What are the security layers? What are the privacy layers? And last but not the least, the algorithmic lens, which is your process lens. Now, even though specifically I'm talking about processes, we need to understand that process is something that will actually apply in every bucket. The way a human interacts with the application is a process. They'll go through certain steps. For example, if you need to submit a medical claim for an insurance or something, there is a process that the user actually follows to interact with the system. And that also falls into algorithmic lens, even though primarily it'll fall under design because you're trying to figure out the user experience. Similarly, even within systems, you will find processes. What is the process of the data to flow from point A to point B in the system, right? So that in itself is a process as well. So algorithm applies within the system lens as well. And then even within the algorithmic lens, you will see the other two kind of embedded because a process is not necessarily standalone. You'll have personas, you'll have actors, you'll have specific people who run those processes, who own those processes, who make decisions in those specific processes, right? And those processes will go through systems as well. So knowing what the system does. So all of these three, even though they're categorized separately, they're very much intertwined to provide you with comprehensive requirements. So while you're thinking of each layer, also remember that they're all integrated. All right, and this is a quick checklist, if you will, to just kind of understand what are the different scenarios we need to think about in each of these thinking aspects. So the way I've broken this down is what is algorithmic thinking primarily focusing on? It's thinking about the process. So there's a lot of questions about efficiency. How many steps are we passing through? How many handoffs are taking place? What are the blockers? What are the value-added steps? What are the non-value-added steps? Sorry, give me 1 second. Sorry, my throat malfunctioned there. The next thing is systems thinking. This is really thinking about how many connection points are there? How many systems do you have to traverse with to complete one process? What is the feedback loop? What is the monitoring software? Who is the person who actually owns these platforms? Because you must have heard about platform ownerships as well. You would have different tech departments that you need to manage. And design thinking, as we talked about, it's all about user needs and empathy and innovation and how they interact. So some of the questions that you would ask here and what are some of the typical tools? If you have heard nothing else that I've spoke in the session today, I would highly recommend taking this comparison matrix as one of your go-to documents to kind of refer back to and see where things are applying. Okay. And then there are typical tools as well. I'll not go into too much detail here, but eventually you can see where the BAs can actually apply it. That's basically your application layer and trying to understand, okay, if I have algorithmic thinking, my deliverables or my artifacts are going to have process flows, integration aspects, and perhaps some algorithms as well. Eventually, I'm thinking you would even have some prompting details in here in terms of your algorithm, because that's you communicating with Gen AI to receive certain outputs, and that would be part of your thinking aspect as well. Then you've got systems thinking, which will give you a lot of output. Again, you can have some prompts in here too, which will specifically talk about, hey, I'm trying to build a pizza ordering system. What should my algorithm look like? Can you tell me, right? And then Gen AI will give you the answer that it's supposed to. Design thinking, again, you can add a prompt in there to kind of say, okay, I am building something like this. Can you research online and tell me what are some of the common user problems that people search for or try to alleviate when they're working with this sort of a software? So this is something that you can leverage, and you can also standardize this based on the domain that you're working in, based on the departments. If you're specifically working with IT in the billing space, your definition might be slightly different from, say, if you're the HR space and you're trying to build IT systems for HR department. Okay. All right. So even though I said in the beginning, I don't think all of this can be constricted into one specific day. I have assumed and attempted to kind of put it into one day, but this is really talking about the sequential movement of what you would do when you're thinking about algorithmic thinking and how you're applying it to your daily work. So often you'll come or you'll receive a request more often than not. It's quite vague. You might be working on a greenfield project. You might be working on a new functionality that you're appending to an existing platform or software. And they might say, hey, we need an AI powered portal for X. Let's just assume it's a chatbot for something, right? And we are providing customer service and we need a chatbot there. The first thing would be that instead of running away and building a solution, I'm hoping all of you are taking a pause and kind of thinking about what is it that we're trying to solve here, right? So uncovering the real user friction, mapping out the user interaction, the customer journey, thinking through the process that the customer is actually following through today. So if they need to reach out to your company, what are the steps? What are the different channels that they're going through? Perhaps they're calling into your contact center. Perhaps you have an in-person branch that they're going through. Perhaps your social media is quite vibrant and active and they start, tweeting something on X or they're posting something on Facebook or Insta. Are they reaching out to their field reps? Do you have specific agents who are connection points who kind of collate all this material? So how would adding a chatbot kind of change that scenery? And who are the people who are probably going to be accessing this? Do you have a population that is quite tech savvy, or are you servicing a population? Are you working in geriatrics, which is specifically for old age or senior folks? Are you working with, different demographics like millennials and the recent generation? That is pretty much always on their phone. Do they even use chatbot anymore? Do they kind of go in with plugins that are connected to Gen AI? What would it be a standalone? Would it be something that's integrated to your app? All these questions kind of start formulating when you are thinking about the user interaction and experience. And that's sort of your front layer that you're going to peel out. And the next thing is you're translating that journey into explicit data mapping, step-by-step logic, edge cases, error cases. And this is where a lot of the algorithmic thinking will come in because you've got one side of your, so if you're thinking about a sandwich, you've got one side of your slice, which is the user experience side. You've got the back end, which is the actual solution that you're going to be putting in. And then meat of it in the middle of those two slices is essentially going to be all your algorithmic thinking and trying to understand, does the user experience match what is being built on the back end, right? So that's where your structuring will come into place. And last but not the least, you can start getting into the solutioning aspects, thinking about all the cross-team dependencies and bringing the variations in terms of this is what I have in my existing setup, and what is it that I need to apply on top of this to make sure that my user experience remains intact. And I'm not necessarily creating a new pain point, but I'm alleviating a pain point that is already there. That becomes very crucial. Often what happens is that's one thing. Let's talk about it and unpack that a little bit more because I intended it to cover it in the AI slide and I missed. So when we just put technology for the sake of technology rather than really thinking about whether it's really needed, one of the unintended outcomes that comes out of it is that you start introducing a pain point that wasn't there before. And because of that, now you have just opened another can of worms, which might not even be obvious to you until much later, which eventually causes the failure of the solution that you've implemented. And you would actually think it's the solution that failed, but it was the unintended consequence that actually led to that. So causation is not correlation, right? So thinking about those aspects as well, and those things are really hard to detect, which is why I truly, truly enjoy pilots because that helps you uncover a lot of these unintended consequences. And I'll go through this in the checklist at the end that I have as well. But pilots are an excellent way when it comes to AI, testing out things in a more controlled environment and finding out how it works before you extend that further. So hopefully the structure that you're following that also helps you uncover those unintended consequences because you don't want to thrust in or throw in technology for the sake of technology. Rather, you want to make sure that it is a viable and a useful solution for that specific scenario. And I think next we're going into, oops, sorry folks, my system's super slow. Okay, so this is giving you an example of the framework. So in terms of algorithmic requirements, what are some of the specific BA activities that you would be involved in? So you might be involved in specifying some sort of calculations if you're doing some very technical work. If not calculations, mapping, and so on and so forth, data transformation, security classifications, routing rules, validation schemas. I know a lot of this sounds very technical, but if you think about the requirements that go along with it, these are things that you've done regularly, right? So when we talk about calculations, you could have defined metrics. You could have defined how a customer's credit score is calculated. You could have defined something like how is an account balance calculated if you're working with investments. I come from a fintech and a healthcare background, so a lot of my examples will be in that space, but you can extrapolate that into your domains as well. You've got data transformations at all times, right? So recently we were talking about insurance application. And what happens is whenever you apply for insurance, you're given a temporary code that is then used to retrieve your application. And once you have paid for the insurance, that's when you get your member ID. So effectively, your initial application code kind of transformed and was morphed into your member ID, which is always mapped in the back end, but there was a transformation that took place there. The security classifications. This is huge for me in the fintech sector and the healthcare sector. We need to think about PII, which is personal identifiable information. We also have something called HIPAA, which is the Protection or Privacy Act that we need to follow. Routing rules. So every time we get claims, we're actually sending it to different healthcare providers because we're sort of the interface of receiving all the claims from the clients, and then we route it to different places. And validation schemas. This is very common, right? Anytime you create a form online, there has to be validation behind it. Once you have an API that goes through, you're validating that as well. So every layer that you're interacting with the system, you've got schemas that you need to follow. I put in a little blurb there about product management focus because I feel like a lot of BAs these days are also tapping into a lot of the product management skills. But here, this is something that I got from Marty Kagan, who is, one of the pioneers in product management in the Silicon Valley, and Melissa Perry, who has actually written a book about agile and lean, I believe. So in product management. So both of them kind of talked about this, and this is basically what they've mapped out, which is very similar to what algorithmic thinking kind of pushes you to think about as well. So the discovery process is really an algorithm in the sense that you understand your market, you understand what is the pain point, and you bring in your unique value proposition. Then you think about what's the core offering that you're going to give, and then you iterate on that solution to keep building up on that product so that eventually you have something that's a bit more robust. And in terms of requirements, you're going through the same thing, right? You've got that initial discovery session where you're trying to ask your stakeholders what is it that they're trying to do. That is your interview process. You're trying to work on the gap analysis at some point. And then as you're discovering the solution with the solution architect, you're discovering what you're going to build. And then you start reiterating it and iterating on it. And every sprint, you're building something new. And then I've got a couple books if you want to read a bit more on these topics as well. Again, take everything with a grain of salt because at the end of the day, a lot of these are focusing very heavily on the development structure of it. But if you're comfortable reading technical books, I would actually recommend reading them, but then extract the business aspect of it or the business analysis aspect of it and apply it to your specific space. Another tip I would say is that pop this book title into Gen AI. And you can also ask Gen AI to be like, hey, can you translate some of the concepts that were mentioned in this book to or for a business analysis audience, right? Or a business analyst audience. So that will help you translate some of the concepts that they've talked about in that book for your specific consumption as well. I think the next one is a case study. Yep. So here, I wanted to cover three different case studies. I think this one is related to Spotify. And here, the recommendation was about increasing sales. So how do we recommend certain things within Spotify to increase the sales that people are purchasing in terms of subscription-based costing and revenue, right? So first thing is brute force complexity trap. So if you're thinking about product recommendation engine is a big algorithm that pretty much every tool now is using. And if you think about all the app interactions that you've gone through, maybe in the last couple days, if you have purchased something on Amazon, if you have picked up a book from a local e-library, if you have gone for any kind of shopping for that matter, any kind of solutioning, even like you had a problem and you were like, how do I do this? Your Google results will always show up recommendations for you. It's actually making the decision based on a certain score in showing you that this result is much better than some of the other results I have below. So recommendation engine started off when I think Google started because it started ranking its results, and that's not very different from this recommendation engine in the sense that it actually assigns a score and it tells you which one's the best one. It takes it one step further compared to ranking. So over here, when you think about brute force complexity trap, you're trying to solve for this problem. If you were to compare every customer with every product, you're just going to have infinite permutations, right? There's going to be so many different permutations in terms of what their match is going to be like because match means a match, match means a partial match, match also means no match. So match, if that was a variable, you could have three possibilities. And if you think about no match, anything that wasn't a match becomes a no match, right? So if you were to store that entire data set, it's going to be a huge calculation that you need to perform. So when you're thinking about these recommendation engines, you really want to think about how you can scope it in to make sure that you are really focusing on what needs to be focused on and not just expand your whole thing. So in your algorithmic thinking process, you would slowly eliminate a lot of things and saying that, okay, these things don't make sense for me. So here, you've got some of the inputs that you're taking. You're taking the user's active browsing history. What kind of songs have they listened to before? What kind of artists have they searched for before? What is the device metrics? Like sometimes I don't know if you know this, but apps talk to each other as well in your phone. So it's not just right now, if I have my phone right next to me, it's actually listening to me as well. And sometimes I just turn on Google search and suddenly it's talking about things that I barely mentioned in passing with someone else. And I'm like, this is witchcraft, right? But your phone is listening to you. So it's actually taking in input from various sources. Then you've got your decision logic to kind of understand, okay, what is feasible within my scope? What is feasible within the data that I've received? And what is feasible in terms of how much I can store? All these different things kind of end up leading you to a conclusion of what you need to build. And then you start thinking about all the edge cases. Yes, this person may not have searched for this specific artist, but then it's a new artist that they've not heard of before. They may like it. How do I place this person in front of this user? How do I bring this artist and introduce them, right? And that becomes your user experience design that you talk about. And last but not the least, you have a dynamically ranked list of 5 product IDs, and that's delivered to the UI and saying, hey, these 4 people seem to match your previous taste, but this one person seems to be new, but then we think you like this person because we can identify some trends and similarities of other people who have actually similar tastes as you, and therefore they like this artist, therefore you might like this artist, right? So this is sort of a case study in the recommendation system space, which leveraged the algorithmic thinking in terms of how it went through the whole process to deliver the output that it did. I hope this is making sense. If not, please feel free to put some comments in the chat. I'd love some feedback to make sure that you are following through what I'm saying and this makes sense. Can I get a thumbs up if so far whatever you've heard makes sense to you? I hope it's not too late in Ireland and people haven't nodded off to sleep. Yes, thumbs up. Anyone? Does it make sense so far? Okay, thank you. Thank you for interacting. All right, another example. So I come from a banking background, so obviously I have to put in a banking example as well. So this was related to real-time fraud detection. So I used to work in a department where we tried to detect fraud for credit card transactions. And these were some of the things that we used to think about. I cannot give you the entire business secret, but these are some of the interesting things that we used to look at. The first one was geolocation distance. How far are they from the normal space that they make transactions? So if you're away from your home or your normal city, have you set up some sort of travel alert? And these days, you don't even need to set up travel alert. It actually detects if you have booked any tickets for a specific location, and if you're making purchases in that specific location, then it doesn't even pop up those alerts. So there is some complex algorithm that they have started building in now that you don't even require someone to notify you that you are traveling somewhere. But geolocation distance was a thing. Like we used to look at how far. So, thieves will usually not try to use the card in the same location. They will try to use it somewhere far off when they feel they're safe. So that used to be a trigger. Device footprint. So was this actually unlocked with your device, or so when you're paying your card using your NFC technology on your phone, what is the transaction velocity? Like how often are they making transactions? So if it's someone who's creating fraudulent transactions, they want to withdraw as much money as possible in the shortest amount of time before someone even detects that they're making a move, right? So if you see like consequent transactions, just one after concurrent transactions is the word I was looking for. Concurrent transactions in a very short period of time, you know that a thief has struck. Or there might be some serious issues that might have befallen the user. And if that's the case, we would send a call out from our fraud center to make sure that the person who is completing the transactions is indeed the person who's supposed to. And then you've got your baseline spending profile. So if you know someone does not spend more than like $1,000 a month and suddenly there's like a huge spike of like $50,000 a month, you want to know if that was some unique purchase. Maybe they purchased a car. It's completely possible, but you would want to flag that anomaly so that someone, a human in the loop, then goes in and kind of looks at the transaction and decides, okay, this kind of makes sense, this doesn't make sense. It looks like this person had also applied for a loan for something else. So that kind of matches with this. They must be having some sort of a house deposit or whatever it is. They must be using it for that purpose, right? So you have all these different inputs, and then based on that, you can create the rules. And then based on the rules, and then you translate that into machine speak as well. So you've got a risk calculation score that comes up based on these inputs. And in that risk calculation, you start telling AI or the model to say, okay, if the risk calculation is less than zero point 0.3, auto approve the transaction. If the risk calculation is between zero point 0.3 and zero point 0.7, you might want to send an SMS and make sure that they're able to enter the OTP. If they do, then that's successful. If it's more than 0.7, make sure that you lock the card and you notify the human and say that, hey, something's wrong with this case. And that human can then call up the person and be like, hey, is everything okay? And once they've gotten a confirmation, they can unlock the card. So this is the way that you would incorporate AI in the process as well, where you tell it how to calculate the score and then make that recommendation based on what was detected. I think the next one's about systems design modeling. So this one is where you're thinking about the solution. And this focuses a bit more on the solution architecture side. And some of you might be technical BAs, so you might be involved in this conversation. If not, these are aspects that you can think about because there's algorithmic thinking within system modeling as well. And as you are brainstorming with your solution architects, these are things that you can talk to them about. So stocks are essentially your inventory, any kind of like pool of something, right? So your pool of users, your pool of tickets, what is the load of transactions that are coming in, the revenue, the money, whatever is actually something that you can pull in and put in, that becomes your stock essentially. Your flows are aspects that have constant movement, right? So this is the transaction that takes it out, it brings it back in. Those are going to be your flows. So how do systems kind of interact with each other? It happens through flows. Then you've got feedback loops. So anytime any of this stock was done wrongly, for example, you've got account balance of $5,000 and now a transaction came in to withdraw $6,000. That is going to be a flow. Flow in and of itself is not incorrect. It's just asking you to withdraw 600 bucks. But the feedback mechanism is what needs to play in here because the stock will then tell you that, hey, you're asking for 6,000, but I only have 5,000. So there's a feedback loop that is built along with that, which ends up self-correcting that and making sure that you're not withdrawing more than what is needed unless you have overdraft capacity. So all these are rules that you kind of build in. And then you've got delays. And this becomes very crucial in AI as well, because in AI, everyone is looking to do real time, right? You want instantaneous answers. So in the example that we just discussed about the fraud aspect of things, you do want AI to make a quick decision. So this happened to me actually, and I was trying to use my card at the local cinema theater. And for some reason, it got blocked. It was not letting me go through the transaction. Luckily, I had another credit card, so I paid with my second one. But when I called up the branch, they were like, we don't see any block here. But I'm like, I didn't see the transaction go there. That's why I'm calling. I'm not a crazy person that I'm just calling you for fun. But they were not able to detect anything on their end. And that delay cost me a frustrating experience, right? So now think about what will happen if this was applied to the fraud person, the thief who's trying to get stuff out. If we actually respond instantaneously, the company has just incurred a loss of risk exposure because they've let this person withdraw the money. But if it was an actual user and they needed the money urgently, and now you have added another friction point for them to get access to their own money, that's going to be a frustration point. So how do you balance these two? So delays become really important, especially in this age of real time and AI, because we want decisions to be fast, but also safe, right? And then I think I have one last example here, and then we'll go into the Gen AI example and we'll close the session for today. So with regards to system requirements, I got the example of Uber here, and this is a classic example of balancing supply and demand because you want the right amount of drivers on the road, but you don't want too many drivers because they'll get frustrated saying that, hey, you put me out on the road, but then I didn't get a lot of riders. At the same time, you don't want too many riders on the road without having access to a car because now people are like, okay, Uber is not able to service its people properly. It's not able to meet the demand. So thinking about what are the different components that you can quickly keep measuring in terms of managing that delicate balance is how many active riders do you have at any given point? Sorry, active drivers do you have? How many people are waiting? What kind of trust are we looking at? Are these one-time riders? Are these regular users? Are these people coming from like big events, right? Like right now, soccer is happening, it's all the rage. And I'm sure people are using public transport, but beyond that, I'm pretty sure that there's a huge surge on usage of cabs as well. So, are you understanding and aware of the public events that are happening in a specific space, and are you building that into your model? What is the driver satisfaction? Because people who are disgruntled, they'll probably pick up less shifts as well. What is the transit lag? How long does it take for them to go to one place to another? What is the coverage delay? How long does it take for them to get to a space? And I think Uber can really do better here because every time it says your driver is 3 minutes away, and I can literally see them in the map. That would normally take me 7 minutes to get from that spot to the place that I'm standing. And they're really not that great yet in terms of that aspect. So it just feels like 3 minutes takes forever, but it's not really 3 minutes. And then the churn realization lag as well. How many people end up canceling their cab because it takes too long for them to wait and not get a cab? So when you're thinking about the balancing loop, you're constantly thinking about this process of what was the search that happened? How many earnings did I get? Did I end up getting more drivers online? Did the wait times go down? Did it help with the search going down? It's a constant balancing act. And then you've got the reinforcing loop because that same steps that you took, you'll have to take that again to make sure that the system understands. Now you've got AI model that's learning from all the actions that you're taking, right? So the same set of actions need to be applied in a loop, and making sure that the model kind of understands where it needs to balance things to provide a stable structure forever. So that was your example from a ridership perspective. And this was the cheat sheet that I'm hoping you can take away for your workplace and you can start applying. But this just gives you the basics, right? Start with all the basic questions. What are you trying to accomplish? Where does it end? What are the outcomes? And essentially, what are you trying to achieve through this specific process? Who are the players, your persona? What are the manual points? What are the automated points? What are the system interactions? Understanding who's taking the decision, who's actually taking the action, and who is it going to be impacting. So all these users might be different people. Connecting the dots, use all the toolkits that you have, right? So the different types of artifacts that you're building and so on and so forth. And last but not the least, this is something we should always have in the back of our head, scaling up your innovation. Identify the non-negotiables and also know why they're non-negotiable. Because your world might change today compared to tomorrow, and the day after. So what was impossible today might actually be possible tomorrow. So when you're thinking about all the non-negotiables and blockers, always know the why behind it as well. Areas of improvement, bring in your Six Sigma hats, bring in critical reasoning. Are you really, really thinking through what is needed, or are you going to bring in some sort of unintended consequences here? Potential for automation, which will eventually go into your AI solution. Pilot it out within an AI space and then scale it up. So very simple, quick checklist to make sure that you're covering all these aspects. And with that, we have 3 minutes left, and I'll jump over to the um, Gen AI example here. So I have used Gemini, and basically I've just put in an example here, a business analyst with expertise in algorithmic thinking and all the different methods that we just talked about. You also have access to various books that support the framework, and you've been tasked with why clothing specific Amazon returns report a higher loss in terms of merchandise write-off compared to other departments. And this is specifically based on an article that I had read a while ago, which basically said, with regards to clothing, somehow Amazon has a higher write-off, which means that they're not able to put the clothing back into circulation and that just goes into waste. So they're not able to use that again. So compared to that, why is it that this is happening, right? So don't make up any reasons, stick to details based on market research in the space. Consider various elements and provide artifacts that can be used for supporting arguments such as process flows, swim lane diagrams, personas, whatever specific artifacts you're looking for. Think about pros and cons. Start asking AI to do some of the critical reasoning for you, and then you can reason whether or not some of the things it gave was valid, right? Cost and time. These are two non-negotiables for me, so I put that in saying that cost and time to implement as one of the considerations because that's a non-negotiable for me. identify any potential for improvement if AI was used in the final solution, and make sure that this is no longer than a two-pager. I don't know if you guys are familiar with this, but Amazon usually uses a two-pager in all their meetings to ensure that everyone has had the time to read through the problem and they're equally prepared in the meeting room. And now, if you look at the output that it gave me, you can see that it's giving me a bit of a history in terms of why this is happening. It's helping me look at some sort of comparison over here between apparel, electronics, and beauty. It's giving me some aspects in terms of rate of return, primary root cause, processing cost, resale potential. And I'm able to sit through this and think through the research and saying that, okay, so this has become my own customized research paper from which I can take my information for my BA work that I'm trying to do. So you've got this metric, then you've got the various, it does some calculations here. Again, if you're not deep into some of these technical aspects, you don't need to, but conceptually, this made sense to me when I was reading through this. So if the rate of recovery is less than or equal to zero, then system executes, sorry, the value of recovery is less than zero. That means it's negative value. I've incurred a loss. Then these things would be followed, right? So the cost of refurbishment is actually exorbitant because every time I send it out to someone and they return that, it's probably going to cost me more. My risk is higher. And the seasonality is rapid because clothes go out of fashion very quickly. And if you're trying to sell winter clothing versus summer clothing, it's going to be different type of behavior based on the season that you're in. What do you bring in from a design thinking perspective? So these are people who are driving this sort of behavior. So you've got the bracket buyer. So these are people who treat their bedroom as their fitting room. So they order every size because the sizes are inconsistent across different brands. I don't know if you've seen this behavior, but I started purchasing some items from Shein, which is an e-commerce company based out of China. And when you read through the description, it will actually tell you sizing based on Chinese market or sizing based on Asian market. So buy bigger than usual size. And I'm like, how can that be? Like, just make standard small, medium, and large. It's not that hard, right? And then you've got different sizes as well. You've got size 0, 2, 3, 4, whatever it is. I'm sure we can have. You don't need to make like the way we have different plugs across the world. You don't need to make different size metrics. So anyway, this is something that it pointed out. It also did analysis for me from a system design perspective. So it's actually built sort of a swim lane diagram for me to tell me what are the different steps that take place. And it shows me some sort of margin calculations, gives me some financial aspects in terms of what kind of costing is associated with that. It gives me some things that I can move around as well. So if the retail price is low versus high, how does my margin actually change? So it gives me some level of interactivity here. And then key insight here is that for any garment retailing under 40, the return rate above 25% is mathematically guarantees that the cost of triage and restocking will obliterate the gross margin. So it gives me a key insight on top of all the other analysis that it has given me. And then it gives me a section on AI as well. How do I improve this and what do I do in the future? And like I said, AI multiplier effect, right? So this is just something that will happen with AI going forward as well, because whatever you put in, that's just going to be expanded to that much more. It's just going to magnify everything. I know I went through this really quickly. I will put this prompt for you in the deck as well, and I can share that with you. But that was the last slide that I wanted to, or the last piece that I wanted to share with you. I have my LinkedIn link on the page, and if you want to scan this QR code and give me feedback on what you felt about the session, will be super, super helpful in my improvement as well. And over to you, Masha.
Thank you. Thank you so much, Banu, for this excellent presentation and the time that you gave us today. Uh, any questions from the audience? Quick questions for Banu.
I know I went over time. I'm notorious for this, but I'm happy to stay for a few minutes and answer questions if you guys have time. Oh, I see something in Q&A. With Gen AI tools now helping us create requirements and process flows faster and more accurately, where do you think human algorithmic thinking continues to provide value that AI cannot easily replace? Yeah, so one big thing that I would say that you guys are more well versed with than AI would be is definitely your personal experience that you're bringing to the table. Domain experience, again, you can pull these things out from research, but also be mindful that every business has its own proprietary knowledge that only the employees who are working in that company have access to. For example, I'm working in healthcare industry, specifically in the contact center space. And yes, I can go and search for requirements to build contact center technology. I can go research for ways to improve the contact center space. But there's a lot of client data that is not actually out there in public space. So I can build my own internal Excel tools, Tableau tools, and things like that to identify specific markers that will help me make decisions once I receive the output from Gen AI. So when you think about what is it, and again, this is a separate talk that I go through, but when you think about what can be automated, what cannot be automated, what can be put under AI versus what cannot be put under AI, you really have to think through where are the things that you can repeat. If you don't find that you don't have the data, underlying data to build the AI model, you're not able to repeat with the same kind of outcome, then it's highly, highly likely that you are probably not going to use AI. And let me give you another example. Radiology today leverages AI quite a bit. But would you be comfortable as a patient if someone told you that AI looked at your x-rays and said, you have this disease? And then based on that, you're going through treatment options. It's not going to happen, right? So AI in radiology, what it does is it looks at x-rays, it looks at the database of x-rays that it has, and it says, okay, based on all the other x-rays that I've seen, this is what I think is probably happening with this specific patient. It will give you all the options, but you still need a radiologist to go in and look at it. You still need someone who is understanding the human impact. AI does not understand bankruptcy. AI does not understand the cost of, losing your mobility. Someone who has been walking and then medically they make a wrong move and suddenly now they're handicapped. They don't understand the value of the quality of life that goes down. So these things are still valid even in IT spaces. You're still got your risk exposure, you've got your privacy exposure. If you pass through something that Gen AI does without actually checking, and now people are going to be like, oh, this is the standard that this person has. Now it has personally impacted your image and credibility in the market, right? So you can't necessarily just take whatever AI is doing and pass it through. And if you read I think this was a notorious example that came up, right? Like Facebook basically laid off people left, right, and center. And now it's getting to a point where you will read articles where Mark Zuckerberg is basically saying we regret laying off people. We regret the decisions that we made and we regret laying off people. How this impacts the company's bottom line, different story. He hasn't become any poorer just because he laid off people. But you can see like a lot of the ethical aspects coming in. You can see that the branding of the company getting impacted. How this will eventually move in the future. How will the ethics committee eventually come back and be like, this is not how companies need to perform. All these things are going to change the landscape of the humans involved in this space as well. So I do think that Gen AI is helping you with a lot of tasks, but I don't think humans necessarily will move out of the task because you will still need to know how the work is being done. So the concept of show your work that I was talking to you about earlier, people will still want to know how you arrived at something because they need to build trust in the solution that you're proposing. No one is going to take Gen AI output at face value and be like, yeah, this must be it. I think people still understand the value of having humans in the loop. So that's my personal opinion of how humans will continue to be in the loop. Did that help answer your question?
All right. I don't think there are any further questions in the chat.
Okay,
Yeah.
awesome. Thank you,
Thanks
everyone.
again,
Appreciate the
Banu.
feedback.
Thank you so much for your time. Thank you.
Amazing. Yeah. See
Very
you guys. Have a good
informative
one.
session. Thank you.
Bye.
You too. Bye. Thanks, everyone.